So let's give you guys some more practice. So here, find the derivative of this. Find dy by dx of this. Okay, so press pause and have a go. Okay, so to do this here, take the natural log of both sides. So that would then give you this. Okay, so originally you were here. Take the natural log of both sides. That would then give you this, and then now visualize it as now visualize as one bubble here multiplying another bubble here. Okay, so now you so now you can break this up. So that will then become one block plus this block here. Okay, so now and here you've got the natural log of e. So these two just cancel each other out, leaving you with cos of x. Okay, so now differentiate both sides. So if you differentiate this, it will give you 1 over y. Because y is a function of x, then you've got to times dy by dx. Okay, differentiate this, it will then give you this, and then here you've got to use a chain rule. So here visualize it as one bubble here. So when you differentiate this thing here, it will give you 1 over the bubble itself. So this here is the bubble here. So when you differentiate this, it will be the 1 over the bubble itself here, and then you've got to differentiate the bubble itself here. That will then give you this. Okay, and then because and then you've got to times the derivative of x to the power of 3. That will then give you this. Now it's just a matter of tidying up. So tidy this up. This gets multiplied to the top and blah blah blah. Then it gives you this. Okay, and then switch these two around. Switch these two blocks around. This block goes over here, and then this block goes over here, and then hang on, and then you want to get dy by dx on its own. So you times both sides by this block here. Okay, well you times both sides by y. So remember, originally our y was this, and this is y here, by the way. If you scroll up to the top, y would be this. So you get y times this. Okay, so this is your dy by dx equals this. Get yourself a graph plotter. Plot the two graphs. The red line represents our original y. The blue line represents the derivative. Now use the graph to double check everything. So if you look at this point here, looking at the red line, there's a turning point here. Looking at the derivative, you see at the turning point the derivative will be 0. Okay. Looking at the red line, there's a turning point right here. Looking at the blue line, the derivative is 0. Looking at the red line here, there's a turning point here. Looking at the blue line, the derivative is 0. So it kind of makes sense. Looking at the red line, the derivative should be positive, 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 right into this point here. Okay. Now looking at the blue line, the derivative is positive, positive. It's in the positive, 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 positive into this bit here. So it kind of makes sense. And then let's choose another random point here. Let's choose this point here. Right at this point is the gradient's going down here, so it's negative, 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 negative. Looking at the blue line, it is negative, 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 negative into here, and so on. So here the graph seems to indicate that our derivative here is correct. Okay.